So if you attended last year's foundingGIDE meeting in Japan, that may be a bit of a repeat. I've changed a few slides, but basically it's the same idea as Marie asked me to basically repeat a bit the talk. So it's about persistent identifiers, PIDs, and how basically we could use PIDs in foundingGIDE, but also more broadly in the bioimaging community. So first, what's a PID? What's a persistent identifier? So it's persistent. So first, it's an identifier, which is very important because it's a globally unique string of characters, but it's persistent. That means an organization has promised that they will keep this identifier alive. And because it's persistent, that means it's not temporary. If, for example, you use databases, repositories, or even like collections, you have very often identifiers, but very often they are not like in a way perpetual. They just exist for the lifetime of the collection, and no one made a promise that those identifiers will always exist and that they will be unique. And because basically they are perpetual or almost perpetual and they are globally unique, that means that you have standards and governance behind them. And because research is global, it's international standards. What that means is, for example, if an organization which is in charge of, which is the custodian, for example, of a persistent identifier, for example, for RAID, which is we'll briefly talk about that later, but RAID, which is basically the PID for projects. It was created actually out of an organization in Australia, the Australian Research Data Commons, and ARDC is the primary issuer, if you want, of RAIDs, if you want to mint a PID for your project. Now, ARDC, it's funded through government grants, sorry. So maybe within some time, like 10, 20, 25 years, ARDC will not exist anymore. Well, it just happens that, for example, the equivalent of ARDC in the Netherlands will basically become the primary issuer of RAID. So there are contingency plans. The same for the ORCID consortium, the same for DOI with Crossref and DataCite that issue DOIs. So that's very important for PIDs. And they're accessible and usable for a very long time because if you want something, an identifier that is sort of like perpetual, you need to make sure, for example, that the web link remains resolvable for that time. So you may already know some PIDs. For example, for people, there's ORCID, the Open Research and Contributor Identifier. There's also ISNI, which is the International Standard Name Identifier, something like that. For organizations, there are heaps of PIDs. So there's ROR, the Research Organization Registry, but there's also a lot, for example, in the private sector. There's Ringgold, which is in general in the publishing industry, like either like written publications in research, but also audio publications. There's DUNS and Orbis, which are databases more about the financial life of a business, about its credit ranking. Importantly, for example, Ringgold, DUNS, Orbis, and ISNI, they're not open repositories. To have an identifier, you need to pay for it, but also to consult the repository and check who has an identifier and what's the identifier of a given business, you need to pay for that. So whereas ROR and ORCID are absolutely free. And then there are PIDs for basically things in general, research inputs and outputs, grants, publications, data, software, projects, there are heaps. So RAID, as I mentioned earlier, is for projects, IGSN for samples, DOI is for a lot of things. So initially it was for, like in research, we know DOI pretty well because it was for research publications, journal articles, but now we also find DOI, for example, for data sets, for grants, for software. And so the DOIs are becoming increasingly used now. Now, what's the benefits of PIDs? So as I said, a PID is a persistent identifier, which is a long-lasting reference to a resource or a digital resource. And in that sentence, there are heaps of assumptions and it's very rich in information. So as I said, it's persistent. How do I know it is persistent? It's long lasting, but I said perpetual or semi-perpetual a few times, but how long is long, basically? So for that, there are policies and guarantees that are put in place. As I said earlier, for example, there are contingency plans. If an organization, which is the primary organization responsible for a PID, no longer exists, it's an identifier, so it gives you information about provenance and who's who, what's what, who submitted or who's associated with the resource identified with the PID. It's a resource, so you can give it context with metadata. Who created the resource, who owns the resource, who has rights over the resource, what is the resource, where is the resource? And then very importantly, it's machine readable. It's a reference which is machine readable. That means you don't need to have human intervention. Where can I find it? Where can my machine find it? And that's very important. And that is the very backbone of the research ecosystem now. And as a backbone, so it's kind of like made it like on purpose a bit complicated. It's a PID graph. It basically shows the relationships between various kinds of resources that you have in the research ecosystem. So you have institutions, you have instruments, you have instrument scientists and authors, and then you have like all sort of things like samples, data sets, publications, software. And an institution, for example, people like some researchers and some staff work at an institution. So you can have affiliation. An institution can be a funder and fund an instrument, or fund an author, fund a person through a fellowship, or fund a project. And you have all sorts of relationship like that, and you can map them all basically with a persistent identifier. So the institution, you can identify it with a ROR ID, whether it's a funder or it's a university, a research center. The author is the ORCID ID that we all know very well. And for example, for data sets, you can see, and it's not this graph is not exhaustive. You could imagine all sorts of other relationships that you can see, like you can associate your data set with the instrument that generated it, with the author who created the samples that was then used to derive these data sets. These data sets is going to be used in a publication, and other people, like an instrument scientist, would have contributed to the generation of those data sets, for example, through analysis and by bringing their expertise. So you have all sorts of relationships, and PIDs are really there to really create, to identify all of those resources uniquely and create links between those resources. So very briefly, the main kind of like PIDs in the research ecosystem, and they are all open and they all contribute to fair data. So ORCID, you most likely all know about ORCID, but ORCID is actually, it's not only for researchers, it's for everyone engaged in research and innovation activities and scholarship. Like to have an ORCID ID, you need to be a human being over the age of 18 and who's alive. And in our daily life, we basically, like most of the people that we work with, they qualify for the three criteria. So a lot of people in facilities, for example, who operate instruments. For example, in Australia, very often, they don't have an ORCID ID, but they could have one. And then their work could be, their contribution to research and scholarship could be identified, but also identified uniquely. Then there's the ROR, which is the Research Organization Registry. So if you've heard of ROR before, for example, last time I spoke in Japan in October, ROR had a definition of which organization was eligible for ROR ID. And since then, they have updated their policy because their practice did not really match their official policy. So now it's pretty clear. Who can have a ROR ID? It's any organization that produces, funds, facilitates, manages, or publishes research, or employs or educates researchers. That means universities, research centers, research facilities, publishers, funders, any organization, for example, that does research outreach and provides training can have a ROR ID. But what can't have a ROR ID is, for example, schools, departments, faculties within the universities. And if, for example, you have a research center, and within this research center, you have a facility that provides a service to the research center, for example, but also beyond, then this facility is eligible to a ROR ID. Now, the research center may not want this facility to have a ROR ID because they would feel that it would compete with their own impact or image, but that in this case because they misunderstand what ROR is and what the benefit of PIDs. So I really encourage you basically to look into the eligibility of your ROR. If you don't have one, apply for one. It's free, it's quick, and your facility or your institute or your center will be uniquely identified, and you'll be on good track to track your impact. Then I also mentioned RAID, which is the PID for research projects initially made in Australia. There's IGSN, so that's the International Generic Sample Number. It comes from initially geosciences. The G used to mean geo. Now it's been broadened to any research sample, but it's a material, a physical research sample or specimen. IGSN is fairly new, so I think it's going to take some time before basically practices really align, it's more standard and everyone knows about IGSN and employs IGSN properly. And then there's DOI, which is one that most people know, the digital object identifier. And we know it pretty well in research, but it's really not only for research. It's any physical, digital, or abstract object. So for research, that means both research inputs and outputs. Like in inputs, it's grants, awards, instrument, sample. So IGSN as a PID is now minted by DataCite, which means DOI. So now samples are identified with a DOI, but the backbone behind is IGSN with the IGSN, so like a schema mapped on the DataCite schema for DOIs. Same for instruments. You can actually identify them uniquely with a DOI, but also research outputs that you can identify with DOIs, publications, data, software. I think that's the most common ones. Data and software is still quite new, and there's always the question, like, do you need, like, given the amount of data generated, do all data or data set need a DOI? That's another question. And I would like to highlight two, they're not PIDs per se, but they're like development in the world of PIDs. So first is credit. It's the contributor role taxonomy, and ORCID is working with credit. It's basically this taxonomy of 14 roles to describe the kind of contributions that someone makes in the generation or the publication of research outputs. So for example, when you submit a paper to some journals and they ask you who conceptualized the experiment, analyzed the data, curated the data, who got the fundings, who validated the analysis, making sure that they all make sense and there's no mistake, who supervised, all of that is actually codified in a way through credit. And ORCID is working towards implementing credit. So basically, when you have your, for example, publication listed under your ORCID ID, your contribution to this or your contributions to this publication will also be clearly identified through credit. And there's also, in terms of instrument, there's the PIDinst metadata schema. And it's so, because it's a schema, it's basically, it's like codifies, give common metadata properties to identify instruments. So for example, DataCite, which provides DOIs, has mapped the PIDinst metadata schema on its own schema, so that if you want, and this is what I would recommend, if you want to identify your instrument, you can then use that site and have your instrument uniquely identified. And through your PIDs, basically, so here I took a simple example. You have your instrument and you generate data. And at this simple stage, you can add heaps of information about where the instrument, where the data comes from, where the sample comes from, and also what sort of data is generated and who can have access to the data and when the data was created and all of that. So it's also non-exhaustive here, but you can see you can have heaps of information through your PIDs that are very valuable and ideally or realistically, you don't want any of that information to be entered manually. So I've not pronounced it yet, but basically making your ecosystem underpinned by PIDs will greatly contribute to have fair data. So if you don't know about FAIR, the FAIR principles are for findable, accessible, interoperable, and reusable data. So how do PIDs underpin the findability of data? As I said, the PIDs provide a unique and persistent link to a resource. So that the fact that it's persistent and it's unique really facilitates its discovery. You know, like there's nothing more irritating when at the end of a paper, the authors they meant good, they meant well, so they give the link to their local server where you can find, for example, some supplementary information, and then you come back 2 years later, the URL is not resolved anymore. If they had used a PID, if they, for example, had put all of the information into a DOI, that would not have happened, and that would have been basically resolvable until the end of time, basically. How can you get data accessible with PIDs? Well, you have a persistent link, which gives you ways to locate, assess, and describe the resource. I said I did often describe the resource because, you know, a PID just for a PID and without some metadata is a bit useless. It's through the standardization of identifying and describing a resource. PIDs really underpin interoperability. That's very important. And the reusability is also enabled by PIDs because you have this like persistent link, which is unique, and that gives you reliable citation and reference. And also because it's standardized, it really makes the exchange of data or the exchange of information easier and unambiguous. And I would like also to add that PIDs can also, not can, definitely underpin the CARE principles. So if you haven't heard of the CARE principles, they are principles for indigenous data governance. And CARE means collective benefit, authority to control, responsibility, and ethics. And if you don't know about CARE, would like to know more about it, I really encourage you to go to the website of GIDE, which is the Global Indigenous Data Alliance, where you have more information about the CARE principles. But basically, very briefly, how do PINs underpin CARE? So collective benefit, data ecosystems in the indigenous environment shall be designed and function in ways that enable indigenous people to derive benefit from the data. And in the context of CARE, data is very broad. It's information, knowledge of the indigenous peoples, but also anything related to them, including their environment. That can be elements, for example, water. There can be some sacred environments, sacred sites. That can be plants, that can be animals. So take data more as a collective word for data, information, and knowledge. And with PIDs, you ensure that this data remains accessible, as I said, until the end of time. The authority to control is basically you make sure that the indigenous people's rights and interests in the data are recognized and that their authority over those data is respected. And through PIDs, you can actually track and manage who accesses and who uses their data. Responsibility. Those working with indigenous data should behave responsibly and in the way that they share the data. And that should be in respect to indigenous people's self-determination and collective benefit. And PIDs, because you have this tracking and because you can also have rights, access rights, for example, with PIDs, you actually encourage responsible data management. And ethics, indigenous people's rights and well-being should be the primary concerns for everyone using indigenous data, and PIDs support that, as I said, for example, with the rights, access rights, and all of that. Now, just a few slides to finish. Getting a PID, I mentioned a few PIDs, and many of them are widely used. Some of them are more like quite new, but their adoption is growing very fast. So getting a PID is very easy. As I said, if you don't have a ROR ID, go to ROR.org, apply for ROR ID. It's free, it's fast. By the end of the week, you'll have your PID, you'll have your ROR ID. That's easy. But the thing is, those PIDs are like they have schemata associated with them, and schemata means metadata. So you need to make sure that the collection of your metadata is seamless and without human intervention, because really, who wants to spend their time filling in the information for metadata, or even worse, writing those like random strings of characters to identify uniquely all of your collaborators, the instruments that you use, and the grants that you have, and so on. So what we need for PIDs is a systematic, consistent, and automated way to ingest metadata from various sources. You need to, and most likely where, for example, you generate your data, you're using several information systems. Some information may come from the instrument itself, some may come from the booking system you're using, or from other sources, and you need to have all of those systems interoperable. You also need to have a PIDified ecosystem. By that I mean you need to have adoption of PIDs. So publishers, for example, they have adopted DOIs for quite some time, so it's not a problem. They also have adopted ROR when, for example, you submit a paper and you're assuming that the submission system is not too old, but sometimes when you start typing your affiliation, you have automatically suggestion of the organization, or several suggestions, and that is because in the backend you have ROR that gives you this unique identification of all of the PIDs. And I should say, with ROR, the beauty of it is, for example, if your organization can be referred to using different ways. So for example, I'm at the University of Sydney. Some may call it Sydney University, some may call it Sydney Uni, some may call it USyd. All of that is just synonym, and ROR can really make that unambiguous. And of course, if you start talking about PIDs, you need to have an institutional environment, whether that's your facility, your center, your institute, or your funder, or maybe just like the whole ecosystem in your country, or because that's foundingGIDE in Europe, you need to have a mature environment. That means that they need to know what you're talking about when it comes to PIDs, fair care, and other principles in data management and open science and scholarship. So if, for example, you wanted to have PIDs in your everyday life, I took here the example of an instrument. Your instrument has a PID. Through this PID, you can basically tag all the organizations that are associated with it, the host university, center, or institute, the facility where the instrument is, but also if that instrument is part of a network consortium. For example, if you're in France and you're a node of France Bioimaging, then you can also have France Bioimaging tag in your instrument, and maybe also Euro-BioImaging, if that makes sense. You can also have your funding associated with the instrument tag in the PID, both the grants but for the funders. You can also standardize information. As Francois said, you can use schemata or just control vocabularies, how you refer to the models and the series of your instruments, how to refer to vendors. So for example, in microscopy, you have Thermo Fisher, you have Thermo, some still say Fisher. Some people refer to also FEI because Thermo Fisher bought FEI a few years ago. All of those are synonyms, but you need to have some sort of control vocabularies, ideally, to make sure that you don't have a mess. And also you can have basically standardized technique names. And with PIDs, and that is like, so like ideally, you can also use the PID for reporting to your funders or to your host organization, provided you can link your PID to some laboratory information management system. For example, you can track the usage of your instrument. You can track the number of users. You can track how much data you created. You can track how many research outputs came out of that instrument, how many publications, how many citations of those publications, and most likely for your funder, how many Nature, Cell, and Science do you have? So, PIDs can really enable you that, but that is a bit like dreaming there. So as I said, getting a PID is easy, but you have a lot of preliminary steps first, and it can be a long way towards a PIDified ecosystem. So for example, if you wanted to have a PID, whether it's an instrument, whether it's for data, whether it's for software, do all research outputs, for example, need a PID. Your raw data that most likely you will never look at because you processed your data and this is what you're always going to use. Do the raw data need a PID, a DOI? It's an open question, I'm not judging. What is an instrument? When you have an instrument that has several modalities, does each modality need to have a PID, or that's the whole thing, the whole like physical object in the room that has a PID? Should the camera have a PID? For example, for a microscope, in EM, if you change the camera, can change sometimes the capability of the instrument a lot. Then if you ask your institution that you want to have a DOI for your instrument, do they actually know what you're talking about? If you want to have a raw ID for your facility and you ask your institution, do you know who to ask? Most likely they won't know what you're talking about, so they will say no. If your facility is, as I was said, sorry, and also as with all things with FAIR, it's a cultural change basically. And before concluding, I will just remind everyone that at the end of the year, there's the foundingGIDE event in Australia. And it will be just squeezed between International Data Week and eResearch Australasia. And eResearch is a really fun conference, and really it's a very social conference. So if you can come to foundingGIDE, please stay a bit longer for eResearch, or please come a little bit earlier for International Data Week, or if you can, just come to Australia and stay for 2 weeks. Thank you, everyone.